for the CVP practice problem, we're going to again go to session 15 and then go to CVP in-class exercise. So I'm going to once again pull up these equations. So this is here, I'll write it. This is your contribution margin income statement that you'll need, and these are the equations that you'll need for this question. Okay. So the question looks like this. So why don't you try this first part? It says, it gives you a bunch of the costs for one product in one unit. And the question 1 says, prepare a contribution margin income statement for 10,000 units. So why don't you try preparing a contribution margin income statement and prepare it for 10,000 units and not just one. Okay, so to start, your revenue will just be that 10,000 times the price per unit, which is 13, so that's 130,000. Materials are a variable cost unless it states otherwise, which it didn't. So we're going to subtract them. Direct labor is a variable cost unless stated otherwise, and it stated it here too. So that's 15,000, and then it says variable manufacturing overhead because it's a variable cost. Yeah, it's a variable cost, sorry. And so this one kind of gets people the sales. So it says 10% sales commission. Now, it doesn't explicitly say that if you sell more items, you get more, but because it costs more if you make more revenue, which is price times quantity, then that's a variable cost. So even though it's SG&A, it is variable because when you sell more, this cost goes up. So the contribution margin then would just be that revenue minus all of these variable costs. So next we have the two fixed costs right here, which will give us our operating profit of 12,000. And you can check because this 12,000 is the same as this 1.2. It's just in terms of that 10,000 units. So one thing to note is our contribution margin. This is important. So we have this $72,000 as our contribution margin, and our overhead, our fixed costs will total $60,000. So these two we're going to plug in a lot. So yeah, now we get to our first question, and we don't need the top anymore. So for this first question, why don't you try calculating the break-even units and revenue for Space Shot? And again, you're going to want to use these equations to the side. So why don't you try that out? Okay, so we want to start, again, so break-even units you might have seen are right here. So break-even units equal your fixed cost divided your contribution margin per unit. So we know our fixed costs are $60,000 and our contribution margin per unit would be $7.2. So our contribution margin percent, so break-even units would be the 60,000 divided by the 7.2, which then equals that 8,333. For break-even revenue, it's just the fixed cost divided by CM ratio. If we know our contribution margin is 72,000 and our revenue is 130,000, then our ratio would be 55.38%. So the 60,000 divided by that 55.38% will then equal 108,333. And one thing to note that I forgot to mention earlier, contribution margin percent can either be your contribution margin per unit divided by your revenue per unit, or it can be your total contribution margin divided by total revenue. Because it's a ratio, it's not going to change no matter how many units you sell. Okay, so let me just delete this question. So now, with these same numbers, why don't you try to calculate the number of units that you'd have to sell to earn a 15% return on sales. So remember, we have target profits over here, and we have a target profit for if it tells you the target profit, and a target profit for return on sales. So why don't you give it a go real quick? Okay, so to find the number of units that are required, we know that units required to the side equal required revenue divided by price per unit. However, we don't know required revenue yet, so we're going to have to find that first. And so we're going to use this first required revenue, well, the second equation for required revenue. And the reason we're not using any of these is because it doesn't mention tax anywhere, so we're going to assume it's without tax. So the equation for revenue required, if you're given the return on sales ratio, is just your total fixed costs divided by your contribution margin percent minus your return on sales ratio. In other words, your target percent. So that will equal just your total fixed costs, which are 60,000 divided by your contribution margin ratio, which would be that 72,000 divided by that 130,000 minus your return on sales ratio, which they give you is 15%, so that's 0.15. So if this equals 148, yeah, perfect. So this equals 148,571 units. And then if we just divide that by the price per unit, which is $13, then we'll get our 11,429 units. So perfect. Okay, now to the degree of operating leverage. So for this fourth one, it says calculate the degree of operating leverage at the current volumes. So why don't you try that out for a second? Okay, so we know that the degree of operating leverage is just contribution margin divided by operating profit. And we can use those in total or per unit. So we're just going to find our contribution margin and operating profit, which are 72,000 and 12,000. So our degree of operating leverage would just be that 72,000 divided by the 12,000, which equals 6. Okay, so again, we know that this degree of operating leverage times the increase in sales will give us the increase in operating profit. So remember, I'm just going to write down equals 6 just to keep us reminded, and I'm going to subtract, get rid of these. Okay, so in this question it says calculate the operating profit if sales units increases by 15% next year, and using the same cost structure, and then it asks you to compare that expected growth with your degree of operating leverage. So it wants you to kind of check to see what would happen if you increase your revenue by 15% and kind of work through all of these. And then, so why don't you try working on that, and then afterwards I'll give that answer to you, and then you can try to do it with the degree of operating leverage. So take a second just to solve and see how your profit would change if you increased this by 15%. Okay, so if you increase your revenue by 15%, then your variable costs would increase accordingly, and so would your contribution margin. Now we all know fixed costs stay the same. So then your operating profit would end up being increased also, but not just by 15%. So we can check to see that our expected profit increase would be that 15% times the 6th degree of operating leverage, which equals 90%. And we did that because, remember, we used degree of operating leverage multiplied by sales percent increase to find operating profit increase. So if our degree of operating leverage is 6 times 15, and we're all pretending these are in percents, then I'll mean it'll increase by 90%. So perfect. So then we expect it to increase, our operating profit to increase by 90%. So if our operating profit was originally 12,000, actually I'll make this black first. If our operating profit was originally 12,000 and we multiply that times the 1.9, then we should end up with that exact 22,800. And again, the math I did for that, because it was gray, is that $12,000 starting point times that expected 90% increase, so 1.9, gives us that $22,800. So that's how you use these equations. You kind of just plug and chug after you find your contribution margin income statement. It'll get a little more complex with the next part, but not by too much.